All right, Geo, let's just go through some geometric proofs here. This is just some of the angle addition, segment addition, and some definition stuff that we have going on. So just more practicing, more trying to piece what we have going together. So right here in this one, we have given a line segment, and they're giving us all this business right here, okay? So we're going to take this and write that in the statements. How do I know that? They gave it to us. All right. Well, what do we know? If they give us a segment, this is the part plus the other part equals the whole. That is the segment addition postulate. The two smaller parts equal the whole thing. And then it's going from the segment addition postulate then to taking the two parts, adding it together with the values in there. So all we did is we substituted the values in. I'm all right if you put this 2x plus 25 as the segment addition postulate. So if you took this step here and saved ourselves a step this and put it here, I'm all right with that, okay? Now it's just the algebra. So from here, it's getting the algebra, how and why can I set the algebra up that way, and then now it's just a matter of doing the work, right? So we're going to get 3x plus 45 equals 12. And then over here on the right, they're giving you a hint, subtraction. Well, what would I subtract? Minus 45 to both sides. And then we would call that simplify or collect like terms when you get down to that. And then we would do the division property. And then simplify x would equal negative 11. So now we have to figure out, it says up on the top, prove ij is equal to 3. Okay, so now we're going to take and substitute that in. And then when you do your math, negative 22 plus 25, and you simplify that down, you get that equal to 3. We also, so never mind. I was just making sure ij, we have to make sure that was at the beginning part. So then when we substitute it back in, if it wasn't involved in this given piece, then we would have to state that at some point. Okay? So that was segment addition. This is also going to be segment addition. So if you don't have a picture, draw it out. M is a point. So it doesn't say the midpoint. It just says M is a point somewhere on there. So hey, this looks like a segment addition postulate. Prove NM is 24. So I got to show that this is 24 right here. Well, the way to do that, since they're giving me NM, MO, and NO, I am going to do the segment addition postulate again. What I would do, though, is I would pause the video each time and try this out before I do. NM plus MO equals NO. Okay? Segment addition postulate, then you plug the values in, substitute them in. 3x plus 4x minus 8 equals 48. Substitution. And then now it's just going to flow just like the other proof did. 7x minus 8 equals 48. And that was simplify or collect like terms. And then we're going to add 8, addition postulate. And then simplify it down. And divide by 7. And then we simplify that down. Then we had to prove what NM was 24. So then now we're going to take what MN equaled, which was 3x. So we would say NM is equal to 3 times 8. We substitute that in. And then MN equals 24. We simplified to get that. Okay? You're going to find out that this one is pretty much the same thing as the one we just did. They give us RST. Again, if you don't like looking at it like this, I draw out the big outside angle as the straight line so you can see what the whole entire thing is. And then this would be U here. So RSU would be on the left and UST would be on the right. And they give us RST is 171. So the whole thing is 171. RSU is 70x. And TSU or UST is -1 plus 16x. Right? So they gave us this. The part plus the part equals the whole angle is the angle addition postulate. And then we would add all that business up. So we would say 70x minus 1 plus 16x equals 171. And then it's substitution. Collect our like terms, so we're going to get 86x minus 1 equals 171. Now simplify. And then we're going to do the addition postulate. Or addition property of equality. And then we're going to simplify that bad boy down. So we get 86x equals 172. And then we're going to do the old division property of equality again. We get x is equal to 2, so that's division property. So a lot of the geometry that we're doing here is by definition, okay? Once we set up the geometry piece here, using the angle addition postulate, that's the big geometric piece here, and then prove TSU equals 31. Well, TSU is -1 plus 16, so we're going to do -1 plus 16 times 2. That's substitution. And then we're going to simplify at the end. So measure of TSU equals -1 plus 16. And then you simplify the math, you get 31. All right? Last one, OMW and GMW form a linear pair, so that measure of OMG equals 180. And they give us all of that stuff. So what are we going to write? We're going to write all this business. In the given, OMW plus GMW equals 180. How do I know that? That's a definition of linear pair. So that's like the geometry again. What allows me to say they add up to 180, that's the definition of a linear pair. And we're using that because it says form a linear pair, so we're going to use the definition of linear pair. So if they give you something, you're going to use it. Okay, not going to make this up out of thin air. So now OMW is 13x plus 8. Whoa. Plus GMW, which is 7x minus 8. That equals 180. A substitution. And then now it's just simplify and do our algebra, right? I'm sorry, collect like terms is what the one either way. Collect like terms or simplify is the step that we're doing. So this is going to be 20x and then 8 minus 8, right? Just making sure 8 minus 8 is 0, so we get 20x is equal to 180. And now we're going to do a little division property of equality. Looks like that's going to be 9, so and then we got to prove OMW is 125. So 13 times 9 plus 8. Morning, Mr. Sanisolo. Just finishing up a quick video here. Oh, no, you're all good. And that's going to give us, weird, OMW equals 125. So we substitute. Wow. Can I write any sloppier? And then simplify. So if you were hammering out and doing all of those algebraic proofs, then literally it's the geometry comes from this piece right here. Is that definition or that postulate that we're going to use to set up the algebra, and then we blow through the algebra. So let us know if